So hello everyone. Today we have the topic, as you can see on the thumbnail. Our topic is right now is the preparation of alkyl halide. Alkyl halides. How can we prepare the alkyl halides? So how can we prepare the alkyl halides? There are various methods of preparation to prepare the alkyl halide. The first one is from alkenes. From alkenes. From hydrocarbons. First of all, what hydrocarbon we have to take here is alkene. We can prepare the alkyl halide from alkenes also, but here we'll take the alkenes first and we'll go for the alkenes in the second video. So in this video we are going to discuss how can we prepare the alkyl halide from alkenes. So first of all, if I tell you that I have an alkene has double bond carbon carbon, and then there might be the another carbon and their hydrogen satisfying the valency of the carbon, the hydrogen, two hydrogens, three hydrogens here, one hydrogen here, another here and another here satisfying the valency. If I add it in presence of hx, what does hx mean? Hydrogen means H and X means X can be fluorine, chlorine, bromine, iodine. Okay, this can be any halogen. So this is halogen acid, or we can say it can be, if it is fluorine then hydrogen fluoride, if chlorine then hydrogen fluoride, if bromine then hydrogen bromide, if iodine then hydrogen iodide. So when alkenes are treated with the halogen acids, it will give us the addition reaction. What does addition reaction mean? See what will happen alongside this double bond. There is the electronegative difference between this hydrogen and this X. If you are getting me, the X is by the fluorine, chlorine, bromine, iodine. It's more electronegative, so it will attract the shared pair of electrons towards him. So the del negative charge will arise on it, and the del positive charge will arise on the hydrogen atom. Okay, here is the double bond. The double bond is reactive as compared to single bond, so it will react with this, with the charges arising from del positive and del negative due to the electronegative difference between the two. So what will happen? The double bond will break. Okay, when it will break, it will leave the valency. It will leave the valency of carbon unsatisfied. Okay, here is hydrogen, and there would be another carbon which would be having two hydrogens right now. So the valency of this carbon, is has been unsatisfied. Okay, so what we'll do to satisfy the valency, we'll give one carbon the hydrogen atom because it has positive charge, and it will react with the negative part of the double bond, and the negative charge will react with the positive part of the double bond. Okay, here will come the X, or we can say the halogen. So here we will get the product of alkyl halide. So we'll get more detail of this this reaction in mechanism. If we see the mechanism of this reaction, we'll get more details, and we'll see how come the hydrogen is being added to which carbon, how come the fluorine is being added to which carbon. So that's the most important thing, to which carbon you will add hydrogen, to which carbon you will add the fluorine. So first of all, we'll see the mechanism of this reaction. So we'll take the compound as we have taken earlier, that was CH3 C double bond CH2, and here is the hydrogen. So what will happen? The double bond would shift. The double bond would shift. But from where side? From which side the double bond will shift? Will it shift from this carbon, or will it shift from this carbon? So it is the thing to be learned right now, whether it will shift towards right or whether it will shift towards left. So first of all, we have to see, if we shift the double bond towards this carbon, what will happen? The CH3, then CH, then the carbon CH2 would get negative charge, and this would get positive charge. Getting my point or not? So as you know that when the charges are being created right now here, so we take here the HX molecule also, and this is del positive and this is del negative. The negative charge developing on this carbon will attack this hydrogen and will get separated. The hydrogen will get separated from the the hydrogen halide, and it will the hydrogen will get added to CH2, and later on it will form what CH3, and the charge would be neutralized. The negative charge would be neutralized on this. The another possibility is if we break the double bond towards this carbon, what will happen? The CH3, the C, okay, the C and then CH2 will be like this, and there would be the main hydrogen present on the carbon. What will happen? The another hydrogen would be attacked because it's positive charge. It will be on this negative charged carbon from which the double bond has been breaked. So here will come the another hydrogen atom. So, but the fluorine will come like this. So here would be formed the positive charge. When the bond will break, that on the tail of this the arrow, on the tail of this arrow, the positive charge arises. So here will be positive charge. Okay, if you tell me here is the positive charge, here is the positive charge, they both are carbocation. They both are carbocation. Can you tell me, if they both are carbocation, which one is stable? The secondary carbocation. This is the secondary carbocation. This is more stable than primary carbocation. So this compound is stable. So I think the bond will break towards this carbon. Okay, so the bond will break towards this carbon, and it was said by Markovnikov. According to Markovnikov, he said that the intermediate of this reaction is what? The intermediate of this reaction is carbocation. When the carbocation is stable, the reaction proceeds through that mechanism. So here the carbocation is being formed is the secondary carbocation. So it would be favorable for the reaction to it will be favorable for the double bond to be break towards this carbon. Okay, fine. When the carbocation is formed, this is the first step. When the carbocation is formed, and this is the slow step. Why slow? Because this was the neutral species and this positive charged species. So a compound never wants to be in the charged state. So it is unstable as compared to the previous one, this one. So the reaction will proceed and will take more time than expected. So this is the first step of this reaction. So in the first step, what happens? The carbocation is being formed. So the next step, if we go towards the next step, what will happen? The carbocation here formed, CH3, CH, and then CH3. What will happen? The carbocation here formed would be attacked by this X negative, because here the X negative has been released I mean as a negative charge on them. So what will happen? The negative charge will attack the carbon. So when the negative charge will attack this carbon, the halogen will come like this, and it will be CH3. Okay, the valency of all the carbons has been satisfied, and it will give us the secondary alkyl halide. The secondary alkyl halide would be the product of this reaction. So according to the rule says the Markovnikov's rule, Markovnikov's rule Markovnikov's rule provides the insight. Provides what? It provides the insight to tell us from which side in the unsymmetrical, if this is unsymmetrical alkane, from which side the bond would break. And it is said that the bond will break towards that carbon, which makes later on the carbocation, which is more stable, as we have been seen in this reaction. Okay, so Markovnikov's rule, actually you can see it by yourself also, from which side the carbocation is being stabilized. It is a favorable path for that reaction. So this is the overall reaction when the where the alkene is being converted into alkyl halide. But there arises some more questions. Okay, it's not gonna be for board exams, it's simple, but for competitive exams it's not gonna be so simple, because there would be a reaction. For example, this is the unsymmetrical alkene, and there is the double bond right now here. And if they tell you that here is HBr in presence of H2O2, what would be the product? And you will get into your emotions and will tell that the positive charge will be developed on this, then halogen will attack on this and hydrogen will attack on this. So this will be the product, and this will be your the biggest mistake of your life. So what is actually here, the additional thing is this H2O2, or we can say here is a peroxide. In terms of peroxide, the anti-Markovnikov's rule is being followed. So what is anti-Markovnikov's rule? It suggests that whenever there is an unsymmetrical alkene, so the hydrogen will get to that position where we have less amount of hydrogen atoms. So it will get like this, and the halide part will get towards that carbon which has more hydrogen atoms. It's reverse to the Markovnikov's rule in presence of peroxide. We'll see in another video how come the peroxide affects the reaction. How come the peroxide affects the reaction? So it would be decided and it would be checked on the next video. Till then,